Okay, so this is the Math 3 Unit 2 Objective 6 lesson, and so this one is on factoring. So we are going to be doing what are our sums and differences of cubes. So instead of difference of squares, we're doing cubes. And so what's nice is that for cubic factoring, we could either have addition or subtraction, whereas if it was squares, we can only do subtraction, right? Okay, so in order for us to do that, we need to make sure that we take the time to memorize some cube roots, right? So we want to make sure we have some cube roots memorized, or at least have the ability to figure that out via our calculator, right? Okay, so in order for us to do that, so for example, if I do the cube root of 8, that's equal to 2, and it's equal to 2 because if I multiply 2 by itself 3 times, right, 3 times because it's a cube root, that would give me 8, right? Or for example, the cube root of 125 is 5, and that is because if I multiply 5 by itself 3 times, I would get 125, okay? So we need to make sure that we are memorizing that. So we are just going to also memorize the cubic factoring pattern, okay? So cubic factoring pattern. So if we are given two perfect cubes, whether we are adding or whether we are subtracting, then this is the pattern we are going to memorize. Okay, so this is the pattern we're going to memorize. So the first thing we pay attention to is that we have to find the cube roots of both, because that's what's going to go in here, right? So we take the cube root of both of these, and that's what goes here. So these are our cube roots. So whatever that number is, whatever that number is, that is what goes here once I cube root it. And then that gives me my binomial, meaning my two terms. So my binomial is the cube roots, and then the trinomial, so it's always going to be 2 terms and then 3 terms. So binomial, trinomial. Got to remember that, bi and tri. So binomial, trinomial. So then for the trinomial, we take the square of the first root. So if that was like, say, a 5, then that would be a 25. If that was an x, that would be an x squared. If that was a 3, that would be a 9. So we square. And then for the middle term, we multiply our two roots together, but we have to make it opposite. So I would multiply these together. So say if that was an x and a 2, so that would be 2x, but negative 2x. Or if that was like a 3 and an x, that would be 3x, but negative 3x. If that was x and negative 4, then this would be positive 4x, right? So always opposite on that one. So we always need to make sure that we are opposite, right? And then the last term of the trinomial is the square of the second root. So the square of the second root. So b times itself, b squared. Okay, so a couple things to know. A binomial and a trinomial. This is the roots, and then I square, multiply by opposite, and square. So square, multiply, square, don't forget to do opposite. So some people use a way to check the signs, because sometimes we forget how to do the signs. So we do it by what they'll call SOAP, so SOAP. So we know that this sign right here should be the same as the original, so S, same. So if this is a plus, that's a plus. And then this one should be opposite, so OPP, opposite. And so if that's a plus, opposite of that would be a subtraction. And then this one is always positive, so AP. So SOAP, same, opposite, always positive. So same as the original, opposite of the original, always positive, okay? All right, so for the subtraction, it's the same. So my cube roots go here in my binomial, and then I square, and then I multiply, but don't forget to do opposite, and then I square the second one. So square of the first, square of the second, multiply and opposite in the end. Okay. All right, so let's see if we can figure out that pattern. So we want to completely factor the following. So first look for GCF. Can I divide anything out of both of those? And I can't. So then now I want to find my roots. So I'm going to look for my A and my B term here. So my A, I have to take the cube root of x cubed. And then my B, I take the cube root of negative 1,000, but I'm just going to leave it as 1,000 and catch my signs when I do that. So the cube root of x cubed is just x, so that just cancels. And then the cube root of 1,000, so if I don't know it, I can look up here, right? So if I look here, the cube root of 1,000 is 10. And so that's my a and my b, right? So those are my cube roots. So when I go to factor, I'm going to have my binomial and my trinomial. So my binomial are both of these, so x and 10. The sign is the same, so subtract. And then I'm going to square, multiply, square. So square, multiply, square. So I'm going to square this, so x times itself. Then I'm going to multiply these together, so that would be 10x. And this is always opposite, right? So opposite here, so if that's a subtract, this has to turn to addition. This one is always positive. And then I square the second root, so 10 times 10. Okay, so the roots go here, x and 10, and then I square, so x times itself, and then I multiply 10 times x, and then I square the second one, so 10 times 10. This sign is the same, this one is opposite, and this one's always positive. Okay. All right, so if you think you got it, hit pause and try a couple of them. Okay, so let's take a look at question number 2. So I'm going to zoom in a little bit. So again, I want to find my a and my b. So I'm going to look for the cube root of each of these. So GCF first, right? So there's nothing common here. I can't divide anything out of both of those. So then I'm going to take the cube root of 8x cubed, and then the cube root of 1. So the cube root of 8x cubed, so the cube root of 8, again, if I don't know that, I can look up above. So that would be 2. And then the cube root of x cubed, so that would just cancel, leaving me x. And then the cube root of 1 is just 1. So there's my a, there's my b. Okay, so then every time we do cubic factoring, we're going to have a binomial and then a trinomial, right? Binomial and a trinomial. So in the binomial, it goes the cube roots, so that would be 2x and 1, and then this sign is the same as that one. So if that's a plus, that's a plus. And then over here I'm going to square, multiply, square, and checking my additions and subtractions. So square, multiply, square. So square, meaning I'm going to take this guy right here and multiply it by itself. So 2x times 2x. Then I'm going to multiply, so 2x times 1. And then because that's addition, this will be subtraction, opposite. And then square again this guy here. So 1 times 1, and then always positive. So my cube roots here, so that goes here, and then that sign is the same. This one is opposite, so opposite, and this one's always positive. And then to get this guy, I squared 2x times 2x, and then I multiplied, and then I squared 1 times 1. Okay. All right, so if you haven't already, press pause and try number 3. Okay, so for here we have GCF. And so I want to find my a and my b value. So no GCF, I mean, that's what I meant to say. So I'm going to do the cube root of x cubed, which is just x, and then I'm going to do for b the cube root of 64. And if I don't know that, I would look up above, and that is just 4. Okay. And so then here, I'm going to have a binomial and then a trinomial. So a binomial and then a trinomial. So in my binomial, I'm going to have x and 4. And then this is the subtraction, so will this one be, right? So same as the original. And then I'm going to square, multiply, square. So square, multiply, square. So square, so x times x. And then multiply x times 4. And then this is opposite. So if that's subtraction, that will be addition. And then square. So 4 times 4, and always positive. So I squared, multiplied, and then squared. And then this sign is the same. This one is opposite, always positive. Okay. All right, and then let's take a look at number 4. Okay, so for question number 4, I'm going to do GCF on this one. So I think the last 3 are actually all GCF. So I think all 4, 5, and 6 are GCF and cubic factoring, so keep that in mind. So we're going to be doing GCF and cubic factoring. So for question number 4, if I look at this one right here, so for GCF, I can see that both are divisible by x, right? So they both can divide out the x. So when I do that, so I would have, actually let me just do it down here. So I am dividing the x out, so that's my common factor. And then when I divide x to the 4th divided by x, I would get x cubed. And then here the x's cancel, so I would get 27. And so then this is a cubic factoring, so this is just like 1, 2, and 3, okay? So we know we're going to have that x there, that's original, and then we're going to have a binomial and then a trinomial. So then I'm going to do my a and b values up here. So a is going to be the cube root of x cubed, which is just x, and then b is going to be the cube root of 27, which is 3. So there's my a and my b values. So then I will have x and 3, and it's going to be positive, because that's positive. And then I'm going to square, so x times itself. And then I'm going to multiply, but opposite, and then square, so 3 times 3, and then always positive. Okay. All right, and number 5. Okay, so again, GCF. So if you haven't pressed pause yet to try, you should be definitely doing that right now, right? So press pause, give it a whirl, and then forward to see if you got the same answer. Okay, so we're going to start with GCF. As soon as I start. Okay, there you go. So for GCF, I can divide, what can I divide out of both of those? I can divide a 7x out of both, right? Yeah, okay. So when I do that, I will get my GCF and then divide it. So 56 divided by 7 is 8, and one of those x's will reduce, so that gives me x cubed. And then negative 7x divided by itself is going to be 1, so negative 1. Okay. And then let's do our a and our b value over here. Now when I write out the a and the b, that's not something you have to do. I'm just doing that to help explain. Okay. So here I'm going to take the cube root of 8x cubed. So the cube root of 8 is 2, and of x cubed is x. And then the cube root of 1 is just 1. So there's my a and my b value. So I still have that 7x, and then I'm going to have a binomial and then a trinomial. So by binomial are just the roots here, so 2x and 1. And it has to keep the same sign, so it's still going to be subtraction. And then my trinomial, I'm going to square, multiply, square. So square, so 2x times itself. And then multiply 2x times 1. And then the sign needs to be opposite. And then 1 times 1, always positive, 1. Okay. All right, last one, number 6. Okay, so GCF again. Okay, so what can I do here? So I can divide, what can I divide out of both of those? 3. A 3. I can take a 3 and an x out of both, so a 3 and an x out of both. So then when I do that, I'm going to have, so 81 divided by 3 is 27, and then the x's of course cancel, and then plus 24 divided by 3 is 8, and then x cubed. And then this is an addition problem, so I'm just going to flip it around just to get that variable first. If it was a subtraction, I would have left it, but addition is commutative, so I can just flip-flop it. Okay. All right, so oopsie daisy. I forgot to put the 3x in there, so I'm going to erase this. Sorry. So that is a common mistake, because you know if a teacher does it, then probably students do too. So I forgot my GCF, so that should have been a 3x here. And so that's still there, and still going to flip it around. Okay. Right, so if I did it, that probably happens pretty regularly. Okay, so let's go ahead and do A and B. So I'm going to just do it right underneath. So I'm going to take the cube root of 8x cubed and the cube root of 27. Okay. All right, so then for my factoring, so I am going to have my original GCF, which I'm not going to forget this time, and then I'm going to factor my cubic, so I'll have a binomial and then a trinomial. Okay, so in the binomial are just my factors, or my roots, sorry, and it'll be plus because it's the same, so 2x plus 3, and then I'm going to square, multiply, square, so square, multiply, square. So 2x times itself, multiply those together, so 2x times 3 is 6x, and then it needs to be opposite, so subtraction, right? So not addition, but subtraction opposite. And then square, and then always positive, right? So 3 times 3 is 9. So I squared, multiply, and then square. This sign is the same. This one is opposite, always positive. And that's it.